I'm Christian. I lead our sales engineering team here at Dagster Labs, and today I'm really excited to talk to you about Dagster and Dagster Plus. Before I get into a live demo of the product and why I think it's so fantastic, I wanted to take a minute and just describe what is Dagster and how does it fit into the larger platform of Dagster Plus. So Dagster, as you might know, is a Python data orchestrator that is a fantastic data orchestrator. Dagster Plus is an integrated DataOps platform that includes the orchestration engine in Dagster open source and also has data and cost observability, data quality, per pull request environment, staging environments, a data catalog, identity and access control, all baked into one holistic platform. And today I'm going to be walking you through that platform. Today I'm going to demo how data practitioners and leaders can get self-serve observability. I'm going to show you how you can rapidly build pipelines in Python and more recently in YAML. I'm going to talk about how you can have multi-team collaboration within a single platform. And I'm going to show you how your data platform teams can interoperate with legacy platforms. And so, getting value from day one. So let's start by talking about how data practitioners and leaders will get self-serve observability into their KPIs in a single tool. I'm going to jump right into Dagster Plus. So imagine you have you've made it to production. All of your pipelines are running in Dagster Plus. What does it look like to have this reliability by design? What does that world look like? So in Dagster, we believe that Dagster can truly be the single pane of glass for all of your data assets. And what that means is that you can bring in everything from source to data transformation to where it needs to land, all within one place, and even across, like I mentioned, multiple teams and all of those sorts of things. However, when you have a single pane of glass, when you bring everything in, you end up with a lot of assets, a lot of things, a lot of pipelines in that single pane of glass, which can get a little overwhelming. So Dagster also provides you the tools to be able to slice and dice and visualize the different pieces of your data platform in a way that makes sense for you and your team. So these are all flexible saved selections that I've created in our demo environment. You can create your own in your own environments. Here, for example, I've grouped things by team. You could also group things, say, by criticality. How much should you worry about this set of assets? And maybe it's by type. So dbt, Airflow, Databricks, those sorts of things. I'm going to click through to our central data team selection, and we can immediately see a couple of things. First of all, I now have a grouped list by the asset health. And just first of all, when I say asset, what I mean is the outputs of my pipelines. So that could be a table in a data warehouse. It could be a dbt model. It could be a file in blob storage. It could be a machine learning model. It could be a BI report. It could be a pandas data frame, really any of those things. Think of it as like the persistent objects in storage that are the results of your data platform running and the things that your stakeholders care about, right? So for example, I can immediately see what is degraded in health, what is warning in health, and which ones are healthy, which maybe is not as important to look at from a heads-up display. And when we say degraded, we don't just mean that the asset failed the last time it was attempted to be materialized. We do mean that, and that is an important component of what asset health means. But we also include freshness, because it's not just about whether your asset failed the last time it tried to run. It's also about whether it was refreshed within the SLA that the downstream users or stakeholders expected it to be. So maybe it succeeded successfully yesterday, but it was supposed to run today, and now it's 10 a.m. and your stakeholders are saying, why is my data stale? Here in Dagster, we don't have that problem because you would immediately know that it was degraded in health. Same for asset checks, same idea. So you can embed all of your data quality checks, all of the assertions that you might want to impose on your data. You can have those in Dagster and then visualize them and get observability with them inside of this dashboard, inside of Dagster Plus. Here, when we talk about data quality checks and Dagster asset checks, what we mean, there's a couple of things they could be. One, we have integrations. So for example, our dbt integration, we automatically pull in all dbt tests as Dagster asset checks. We also have integrations where you can run, common data quality frameworks like, it could be Soda or it could be Great Expectations. All of those can be run, executed from Dagster and then have status reported, or you can write your own as well in Python. And so you have a lot of flexibility there in being able to not just, have an orchestrator that can run your assets, but have a data quality system that can run and then report status and block downstream runs and things like that based on the whether or not the data in your data platform is of the right quality that you expect. Now, let's say you, as we have here, some assets that are degraded in health. What are you going to do about it? So the first thing you might do is maybe that the upstream problem is resolved and you can go ahead and rematerialize that asset right from here. You might not know, and maybe you want to do root cause analysis and say what upstream of this asset might have also failed or had data quality failures or freshness violations that maybe is the reason why this is degraded in status. Or you could do impact assessment and understand what is downstream, what might be, what's the blast radius of this degradation in health. And so let's go ahead and look at the downstream analysis for this asset, orders augmented, which happens to be a DBT model. And if I look downstream, I can see another big component of the power of Dagster and Dagster Plus. So we have this asset graph, this global asset graph that allows you to see upstream and downstream your entire data platform and be able to view it in whatever way is useful to you. So in this case, I'm starting from orders augmented, and I'm able to go downstream to all of my, the downstream assets and see, okay, I've got some Power BI assets here and Dagster's integrations with many popular BI tools to be able to represent those as Dagster assets. We also see here, we have some downstream DBT models, some downstream pandas data frames, and downstream scikit-learn machine learning models. And if I go all the way out, I think I'll even see some Databricks assets and things like that. So you can really start to see the power of having this global asset graph where I now know what is the impact of this failure. Now, I probably don't want to come in here all the time just to know, to log in every morning. This dashboard is great and very helpful, but I probably don't want to come in here all the time. So I probably want to be able to set alerts and be notified and be proactive and not just reactive. So in Dagster Plus, you can set alerts based on, either all assets or an asset selection similar to what we were looking at here, or you could even target specific assets. Here, I can see, I can target an alert when the asset health changes to warning or to degraded or whatever the case may be. And so here, for example, if I want to set an alert, I can have that go to Slack or email or Teams, PagerDuty, etc. One really powerful thing you can do here is you can set asset health notifications maybe to go to a smaller group of people when they're in a warning status. So maybe you have a warning freshness SLA of say 9:30 or 9:15 or whatever if you have a 10 a.m. error SLA attached to it. So you could notify the data team, let them know, hey, this is, something's out of whack, let's go fix it. And then you can go fix it before the downstream stakeholders are ever the wiser. And then maybe if it gets to be degraded, you can't fix it in time, then a notification can go out to a wider audience and notify the right people at the right time that something went wrong with this. One other aspect of observability that's really crucial is to get insights, real-time insights into what's happening with your data sets. Here, I'm looking at the insights across the entire this entire deployment. I could also filter down again back to those data sets that we were looking at and look at insights at that level as well of any of these selections. One thing to think about here is, software engineering teams have reported and report their SLAs. They are able to report time to recovery and a whole lot of really useful metrics that they've built up over time. And they have the tooling and the resources to be able to do that. And it's always been a little frustrating to me that the data teams of the world don't have anything similar. With Dagster, you, data engineer, can also have nice things. And so here you'll see, we can know how often are our assets passing in terms of running successfully. We can also know how often our freshness SLAs are being met. We can know if our asset checks are running successfully. And we can also track things like time to resolution. So you can see how long does it take from the first time an asset failed to when it went green again, to when it was rematerialized successfully. And so these start to be metrics that you can use to understand the overall performance of your data team and your data platform, but also to be able to tell other stakeholders, this is our historical performance, and these are our targets, and then you can show how often you do or don't meet those. And so here, for example, you can start to look at time series on why, on the different performances for these different metrics within your data platform. You can look at hourly breakdowns as well. And then you can start to, look at things even down to the asset level. And where all of this becomes even more powerful is for comparisons. And so I might want to compare across different selections to know how often are my assets in maybe one group performing versus another. So maybe I want to see how often my DBT models are successful versus my data team's data models, or perhaps I want to check. Maybe not my data team, maybe I want to look at my critical KPIs, because that, maybe is the one that I care the most about. I want to see how often I'm succeeding. And in this case, I see that my critical KPIs are actually lower than any of my other assets we were just looking at in terms of their success rates. And so maybe that's something that I want to look into. And so you can start to see the power of being able to use Dagster Plus as a way not just to orchestrate and run your data pipelines, but also as a way to get deep observability into those data pipelines, and also be able to alert when you need to, and all of those sorts of things. Another really useful feature inside of the observability of Dagster Plus is the data catalog. So I can come in and look for any of these assets that I want to look at. And so here, for example, I'm looking at this asset orders cleaned. You'll notice we have all of the static metadata that you would expect from a data catalog. So you'll see here, we've got the description of that asset. We've got column descriptions. And by the way, all of these are automatically coming in because they're coming from the DBT metadata. So a lot of our integrations will pull those things in as helpful. We know the tags. We know where the table is in the data warehouse. We know that it's going into Snowflake. We can see all that kind of metadata, but we can also see a lot of metadata around the orchestration. So what jobs target this? What schedules target this? Is there a freshness policy? And if so, what's the status? Any of those that kind of information. We can also see how many rows this table has since the last time it was materialized. Again, that freshness policy, the asset check results, and the materialization, and in this case, the partition. So partitions are a way of slicing your data based on time or based on some kind of static feature. And so here, for example, we are partitioning on time so that if I wanted to run this, I could run this DBT model just for yesterday, or things like that. The data cataloging features inside of Dagster and Dagster Plus allow you and all of your stakeholders to really understand the data, understand what is happening, both like the definitions of things, but also the active metadata of the different aspects here. Next, let's talk about how developers can rapidly build pipelines in Python and now in YAML. I think that Dagster has the absolute best developer experience in the business. I'm going to show you a bunch of different ways that it has that it does and demonstrates that. The first way I'm going to show that is by pulling up a Dagster project, and I'm going to run. So if you're going to set up Dagster, all you need is to download Dagster and Dagster Dev, and you run DG Dev. And what will happen is this will immediately spin up a lightweight web server. This will spin up on anywhere. This will spin up on on Windows. This will spin up on Mac. This will spin up on Linux, and it will crucially do that without spinning up Docker or any other heavy dependencies. So it's very fast. The feedback loop is very quick. If I wanted to operate on any of these items, I could make a change, and then I could immediately see it reflected in this graph. That's extraordinarily powerful feature of Dagster. The next part, which we will cover, is this idea of how do you actually do development inside of Dagster. The definition of a asset in Dagster is very simple. So at the lowest level, an asset in Dagster is a decorated Python function with this asset decorator. That's all you really need. You also provide a function that is what it takes to materialize that asset, and then you have a upstream dependency, or you can specify dependencies to build that logical asset graph. And so, that's all that it is at the lowest level. However, you probably aren't going to write this for thousands of assets that might end up in your data platform. And so you can use integrations to make that easier, but you can also use something called components. And so we've built a bunch of components out of the box, but you can also define your own custom components. But before I talk about any of that, I want to talk to you about what is a component. So a component in Dagster is a YAML interface and scaffolding system to be able to create Dagster assets and other Dagster objects without needing to write the Python code underneath. There is also a Python interface, so if you really don't like YAML, you can always use that. But what we find is when you have this YAML interface, this defined schema, both non-technical and frankly technical folks love it because they're able to, it's a lot easier to review a PR or a change request from someone who is adding a new, a new YAML file that follows the specified schema instead of trying to review some Python code where, you really have to look because maybe there's dragons in there. Maybe there's something in there that is going to take you down, do something you don't expect, which is just not possible with a predefined schema. You can also use this to build once and reuse everywhere. So you get to enforce best practices. You can have a template, essentially. You define that template in one place and you reuse it over and over and over again. And others within your organization can do that too. This also allows you to have guardrails. So you can require that certain fields be put into a component. So for example, you could say this type of component needs to have an owner or other types of metadata associated with it. And that allows you to ensure that that's followed and that there's no problems there. So let me just show you a few examples of built-in components that we're using to do different things within our integrations. So the first example I'm going to show you is around dbt. So dbt is one of our most popular integrations. It's the data transformation system. So if you're not familiar with dbt, think of it as a way of executing a bunch of SQL statements in the right order. You have a dbt project, which is a collection of files, of SQL files that define a kind of a DAG, if you will, of like the execution order of those things. So with our, in order to add a whole dbt project, a collection of those SQL transforms into my Dagster project, this is all that I have to do. I instantiate this dbt project component, I point it at the directory of that project, and then I can even do things within here like switching the environment depending on the dbt target, if you will. So this is going to point have things run in different dbt profiles. So like maybe it's running in a dev schema and then a test schema and then production, all right from this this view here, just with these couple of lines of YAML. I'm going to show you another example, which is our Power BI example. So again, maybe you want to ingest a whole Power BI workspace into your Dagster project. So this is all you have to do. Really, strictly speaking, these are the only things that you have to do are those couple of lines here, but then there's also customizability baked in. So you might want to customize the description metadata or other types of things. And so if you do, here's some examples of how you might do that. But the key here is, again, you have this YAML that you can use and review and be able to check how it goes. The last example I'm going to show you is a more complex example. And so this would be a case where, there isn't something already built out inside of Dagster, but maybe for your use case, you want to use it. So in my example, I want to orchestrate an ADF. So maybe I'm running a bunch of ADF pipelines. That's Azure Data Factory pipelines. Perhaps I'm migrating from ADF into Dagster or into dbt or some other system. Or perhaps I want to orchestrate ADF from Dagster, and I want to orchestrate these pipelines from Dagster, but I don't necessarily want to be writing the boilerplate code, orchestrate or execute ADF. And I don't want to make my users, kind of write all of that code. So I created a custom component in Dagster. So this is the Python needed to create this custom component. I'm not going to walk through all of those pieces, but really the key here is to know that this is the Python, and then I'm invoking that in this YAML to create an Azure Data Factory set of assets in Dagster. So these 4 things are the assets that I'm going to create. When this Azure Data Factory pipeline is run, this is what I'm going to execute. Why this is so crucial or critical is that then I can, go back to my local development experience, and I can actually see all of those different Azure Data Factory pipelines, and I can see how they fit into this global asset graph. When I'm thinking about, rapidly developing, I can drastically cut down the time it takes someone to add a new pipeline. So let's say I wanted to add a new Azure Data Factory pipeline. I could add those 3 lines, and then I could, kind of take this YAML, and here's the different pieces I need there. And now I have this pipeline with a couple of different assets. And so I can immediately just get up and running and add a new pipeline. And if I want to make sure that it looks good, I have utilities in my tool belt, so I can do things like run DG check YAML or other sorts of validations and make sure that everything validates, and I can have confidence that this change is going to be good. Another way that we can have confidence that this change will be good is by taking another part of our software development lifecycle that we've applied to data engineering called branch deployments. Let's say I have a change and I'm quite happy with it. I can come in. Here's an example where I've created a pull request in GitHub, and Dagster works with any Git provider, but I'm using GitHub in this example. And you can see I've made a change to one DBT model, and I've added a new DBT model in this example. And because I have this hooked into our GitHub action, it will automatically build an ephemeral Dagster Plus deployment based on the state of that branch. So here, for example, I can come in, I can filter down to something and see what was changed in the branch. Either it's new or it is a code version was changed, and so I can immediately see what was changed. And so maybe this is me, and I just want to kick things off in a staging environment that's using a different environment than my local before it moves into production. Or maybe I'm reviewing someone else's work, and I can, instead of having to clone their branch and spin it up locally and test things out, which would also work, I can very quickly come into this built environment, kick these off, and evaluate the outputs, evaluate the asset checks, evaluate all these things, and make sure that it works exactly as I intend before I hit that merge button. And so another really crucial feature of all of this is that you can use what we call Dagster resources, which allows you to use different compute backends for the same asset code. So as I showed you here, I'm using it's the same SQL files that are changing, but locally I'm going to run this against development resources. In a branch deployment, I'm going to run this against like a staging schema in Snowflake or things like that. And then in production, it's going to run against the production Snowflake schema. And all of that happens behind the scenes based on how the resources are defined. And so it doesn't change how any of this is defined. From a review perspective, it goes really smoothly. And from a testing perspective, you know exactly where to look for those changes without stepping on each other's toes. Between the local development experience, the components, and also with these branch deployments, this is all why data engineers can have nice things when it comes to overall development lifecycle. The next thing I'm going to talk about is the multiplayer experience inside of Dagster and Dagster Plus. So you can think about most of what I've been talking about so far as being pretty good for a single team, right? That's all the stuff I was showing you is very good for like a single team doing their work. What does it mean to have multiple teams collaborating and being able to work together within one Dagster Plus environment? Because if you're going to have a single pane of glass, hopefully you don't have a single place where everything can blow up. So the first place I will start is to show you this idea of code locations. So in Dagster, we have this concept of code locations, which think of them like a project within Dagster. And so each Dagster code location is a Python module. So I can see here, these are the different libraries that are used in these different code locations I have in my demo project. And you'll notice that they might be different, right? And so you can see if I go down, I think to this one, you'll see that this has a very different set of versions than the other ones did. And that's because they can be totally separate versions and still share dependencies and all that kind of thing, which I'll get into in a second. So what that means is that each of these code locations can be loaded separately. And if one of these code locations fails, if the code location for the data science team fails and the data engineering team is still, doing their thing and needs their data to run, that's totally fine. The data science teams might have a failure to load, and then, they can go in and fix it and get everything remediated, while the team for the data engineering team can have their pipelines that have a critical SLA keep on running. The other piece about this, though, right, I talked about having a single pane of glass, is that you can still have a single pane of glass. And so even though we have teams with different code locations, and here, for example, you'll see that we have this this asset locations, which is in this code location Huli data ingest. It is upstream of a asset locations clean, which is in the data eng pipeline code location. So assets are globally namespaced. That means that you can refer to assets across these different code locations, and they can still have event-based triggers and other kinds of ways of interacting with each other and still be reacting based on the metadata of the assets across these different code locations, while still keeping the blast radius separate so that they're completely isolated from an execution perspective and also from a like a Python version perspective. Another thing to highlight with Dagster Plus is that you can do role-based access controls down to the code location level. So you can say the data science team has viewer access on data engineering's resources, but has admin access on their own resources, on their own assets and things like that. And so you can really start to get fine-grained, and so you can have a bunch of different teams that are all collaborating together, all working from one data platform, one single pane of glass, one place to look for all of the different assets within your data platform. So you can give people the right permissions on their assets while still giving them access to this global asset graph. Another piece of this team-based deployment is around our architecture, our deployment architecture. So we have two main modes of deployment. One is Dagster Serverless, and one is hybrid. In Serverless, we manage both the data plane and the control plane. So we basically manage this entire box. We also have a deployment model called hybrid, which is a shared responsibility model. That means that we manage the metadata database and the web front end within Dagster Plus's cloud. And then in your customer environment, environment, you will deploy an agent. That agent could be a Kubernetes agent. It could be like an AWS ECS agent. It could be a Docker agent deployed onto a VM. But the key here is that that agent is deployed in your infrastructure that you control, and there is no ingress from Dagster Plus into any of your systems. So we don't have access to your code. We don't have access to your data. We don't see any of the data being processed, and we don't have access to your databases or anything like that. But because we manage this web front end and all that, you have access to be able to view all of those different deployments or all those different agents, depending on where they're deployed and all of that. You can view them all within one view. And that can be really useful. So here's an example where you can actually use multiple agents for each code location, for each of these different teams, for example. And so it can be a completely separate agent that's running. So from both a Git repository perspective, from a code location perspective in Dagster, and from how that code location is getting executed in Dagster, these could all be in different Kubernetes namespaces. They could be different Kubernetes clusters. They could even be on different clouds, right? You could have one in Azure, you could have one in AWS and one in GCP. Doesn't matter, right? All that matters is that these agents are able to communicate via that egress-only polling to the deployment, and you can still have that single pane of glass. You can still have that one place to look for all of your assets, but you don't have to worry and commingle all of the different execution environments. They can be completely separate. The last thing I want to talk about is how data platform teams can interoperate with legacy platforms and get day one observability and an incremental path to deprecation, or maybe not, right? And so if you think about your data platform, there's a common joke that every data team has three data warehouses. There's like the data warehouse they're migrating away from, the data warehouse they're using today, and the data warehouse they're trying to eventually get to in the future that they've stood up, right? And so if you think about it, that's true for all the tools too. And so I came from a large children's hospital system, and we were constantly doing a huge migration of 10 to 15-year-old data transformations within different tools, and we needed to keep the lights on those. We also needed to run the tools that we had, and try to make sure that those are going, and then also be making improvements and moving towards the things in the future. So Dagster allows you to do all of that kind of interoperability, both for things that you do want to deprecate eventually and for things that you don't. There may be things that you just want observability into, you just want to be able to execute, but you don't necessarily want to destroy them or tear them down or anything along those lines. So when I come over into this global lineage that we looked at before, I'm going to look at this set of assets down here that are our Airflow assets. And so you'll see here we have an integration called Airlift, where we can actually observe with just a few lines of code in Dagster, no changes to Airflow. You can observe all of your Airflow DAGs inside of your Dagster asset graph. And that can be really powerful, right? Because I can then see, okay, here is all of my, here's my configuration, here's the last time it ran, I can know whether it ran successfully, and we're actually using Dagster sensors to pull the status from Airflow and report it in Dagster. So I can see that, but I can also start to see the dependencies. So here, for example, this is what's called an external asset, meaning I can't execute this in Dagster, but I can view the status and understand how it's going. I can even assign Dagster asset checks to this asset. So for example, if I wanted to create like user acceptance tests to say, when this Airflow DAG completes, kick off these 5 asset checks and make sure that everything looks good before my downstream Dagster assets run, you can do that inside of Dagster. Here, for example, you can see that we've got some lineage between our different Airflow DAGs. Another thing that you can do is you can even model the underlying assets inside of your Airflow DAG as a way to understand what's happening in Dagster. So in here, for example, we have a series of DBT models, and we're able to see that when this Airflow DAG is complete, these DBT models are all marked as completed as well, because we know that that DAG maps to those DBT models. And then from there, we can build downstream dependencies either in Airflow or in other systems within Dagster itself. The last thing I want to highlight here is you'll notice this Airflow DAG is actually materializable. And that's because we've set this one up to be able to be executed from Dagster. So if I materialize this, I'm actually going to kick off that Airflow DAG. It's going to run in Airflow, and then it's going to report back whether or not it was completed, and then report back the status within Dagster. So this is a way where I can actually materialize and understand, not just understand, like observe what's happening in Airflow, but actually be able to execute what's happening in Airflow, and then get that status back inside of Dagster. And so you can think about this as a template for any of those legacy systems that you might be trying to either deprecate or just keep the lights on for. And so I showed you that example for Azure Data Factory. We also have similar examples for something like Informatica Power Center, right? Where there's these systems where they're really heavy duty, and you don't, turning them off or moving them from one system to another is a lot of work. And maybe you don't want to do that. Maybe not for a long time, maybe not ever, but you do want to be able to have observability and be able to run them from a central system. And so Dagster empowers you to be able to do exactly that. I just want to highlight the things that we talked about again. So today, we went through how you get self-serve observability and into the KPIs within one tool, how you can have the best developer experience in the business and build pipelines rapidly in Python or in YAML. We showed how you can have multiple teams and can all collaborate within the same environment. They can not destroy each other's work. They cannot destroy each other's, if their code location goes down, they don't hurt anybody else's code location. And but at the same time, they can all have a single pane of glass. They can all see things in one place. And we talked about how you can interoperate with legacy platforms to be able to get observability, and also to be able to either eventually deprecate or just keep the lights on for any of your pipelines. I hope this is helpful. It was really fun to talk about it, and hopefully I wish you luck on your journey.